Gold, admired for its beauty and rarity, has played a pivotal role in human history. This metal's captivating journey, from its ancient origins to its enduring allure, makes it a truly precious commodity. Its scarcity and remarkable properties, including its resistance to tarnish and ease of manipulation, have solidified its status as a prized material. From ancient civilizations to modern times, gold's main use as jewelry continues to shine. Since time immemorial, the noble metal's resplendent luster allows it to be designed into the world's most coveted and exquisite jewelry. Fifth, for queens and kings. Today, most of the gold that is newly minted or recycled is used in the manufacture of jewelry. About 70% of the gold that's available as opposed to stored each year is used for this purpose. Because gold is highly valued and in very limited supply, it has long been used as a medium of exchange for money. The first known use of gold in transactions dates back over 6,000 years. The first gold coins were minted under the order of King Croesus of Lydia, a region of present-day Turkey, in about 560 BC. Gold coins were commonly used in transactions up through the early 1900s, when paper currency became a more common form of exchange. The United States once used a gold standard and maintained a stockpile of gold to back every dollar in circulation. Under this gold standard, any person could present paper currency to the government and demand an exchange and equal value of gold. Possibly gold's greatest use to mankind didn't become evident until early last century, when its fantastic electrical conductivity properties came to light. Solid-state electronic devices use very low voltages and currents, which are easily interrupted by corrosion or tarnish at the contact points. Gold is a highly efficient conductor that can carry these tiny currents and remain free of corrosion, which is why electronics made using gold are highly reliable. A small amount of gold is used in almost every sophisticated electronic device. This includes cell phones, calculators, personal digital assistants, global positioning system units, and other small electronic devices. But the gold is able to amaze us with a bunch of other strange features. So before trying to explain its origin, here are some curiosities. Enjoy them. Gold is the only metal that is yellow or golden. Other metals may develop a yellowish color, but only after they have oxidized or reacted with other chemicals. The chemical symbol for gold is AEW from the Latin word arum, meaning shining dawn, and from Aurora, the Roman goddess of the dawn. Gold is a noble metal. It is relatively unreactive and resists degradation by air moisture or acidic conditions, while acids dissolve most metals. A special mixture of acids called aqua regia is used to dissolve gold. The atomic number of gold is 79, which means there are 79 protons in the nucleus of every atom of gold. The melting point of gold is 1064 degrees Celsius. Gold is extremely ductile. 1 ounce of gold can be stretched to a length of 8 kilometers. The resulting wire would be just 5 microns wide. Malleability is a measure of how easily a material can be hammered into thin sheets. Gold is the most malleable element. 1 ounce of pure gold, 28.35 grams, could be hammered into a single sheet of 9 square meters. A sheet of gold can be made thin enough to be transparent. Gold is one of the densest metals found on Earth. A cubic meter of gold weighs 19,300 kilograms, far heavier than lead 11,340 kilograms per meter cube, and not far off the densest metal osmium, 22,650 kilograms per meters cubed. It is estimated that 142,000 tons of gold have been mined throughout history. Over 90% of the world's gold has been mined since the California Gold Rush. In Tutankhamun's tomb, a coffin was discovered containing approximately 1.5 tons of gold, a stark contrast to the mere 0.2 milligrams of gold found in the average human body, which ranks gold 75th in terms of abundance. In the hierarchy of elements found in the Earth's crust, Fort Knox stores a substantial 4,600 tons of gold. As of today, the price of gold stands at $57.22 per gram. Notably, the visors that shielded Apollo 11 astronauts during their historic moonwalk were coated with gold, an intriguing fact. Yet, it's time to delve into the ultimate question: the origin of the gold we unearth from the Earth's crust. Has it always been there? Or did it have a different genesis? This topic remains intricate, with aspects still eluding complete understanding. What we do know with certainty is that gold, like other heavy elements in nature, can only be forged in immensely powerful thermonuclear reactions, and the only natural locale capable of such reactions is within the atomic furnace of stars. Could this be the genesis of gold? Let's explore this concept by retracing the star formation process. Every star initiates its existence as colossal, compressed gas masses, primarily composed of hydrogen, the first element created after the Big Bang. This hydrogen condenses within the stellar core, giving birth to a swirling mass. The inward pressure is counteracted by the outward force of compressed gas. The ensuing pressure and friction generate tremendous heat, leading to nuclear reactions at the core. Over billions of years, hydrogen ignites and a star comes into being. As hydrogen is depleted, the waning outward pressure allows gravity to further compress the central core, elevating pressure and temperature to around 1 billion degrees. Helium atoms are synthesized as the hydrogen is consumed within this nuclear furnace. The core continues to contract, raising internal temperatures until helium nuclei refuse to form carbon atoms. This process persists, triggering additional fusion reactions that yield oxygen, neon, and other elemental materials. At this point, the core's density reaches around 50 tons per cubic centimeter, a stark contrast to the Earth's average density of 5.5 grams per cubic centimeter. Temperatures soar to approximately 2 billion degrees. Neon triggers fusion, producing silicon, a key component of the Earth. As each new element is consumed, the energy output diminishes. The star doesn't change on the scale of millennia or even years, but instead shifts on a monthly, then daily, and finally an hourly basis. The final phase is reached when nuclear reactions yield an iron core, a more stable element that can no longer undergo fusion. A star's core, about 200 kilometers wide and incredibly dense, contains trillions of tons of matter in just a teaspoon. As the star nears the end of its life, it collapses under gravity's pull, resulting in a shock wave, the creation of heavy elements, and eventually a supernova. Gold, however, is not produced in this process. In the past, it was believed that massive stars and supernovas could create gold, but this idea was disproven in 2017 when two neutron stars collided, producing heavy elements, including gold. To understand gold's presence on Earth, we look back to our planet's formation around 4.5 billion years ago. During this time, Earth accumulated matter, causing heavier elements like gold to sink to the core, while lighter materials formed the outer layers. During this time, Earth accumulated matter, causing heavier elements like gold to sink to the core, while lighter materials formed the outer layers.